Hello students, let's understand one more problem. Here the question says a square pyramid 35 mm sides of base and 60 mm axis length rests on HP. So a square pyramid is resting it on HP. On one of its slant edges, draw the projection of the pyramid when the axis is inclined to VP at 45 degrees. That means he has given the true inclination with respect to VP. We need to find the apparent inclinations. So in this question he did not say it is resting it on edge or corner. So we need to understand the concept before solving this. So here I just representing a pentagonal pyramid, because if I'm going to represent a square pyramid the views will not be appropriate. So just considering the pentagonal pyramid. So here I'm just going to be considering the slant edges, which is nothing but OA is nothing but a slant edge, OB, OC, OD and OE are the slant edges. Similarly, we are going to be considering the base edges, which is nothing but AB, BC, AB, BC, CD, DE, EA. So these are the five base edges. These are nothing but slant edges. Similarly, there is one more thing which is got the lateral faces. Here we are going to be considering for the pyramid as the slant. So if I'm going to be considering the slant triangular faces, which is nothing but OAB, so which is nothing but so this is OAB, then OBC, triangle OBC, then OCD, then ODE, then OEA are the triangular faces. So OAB again to the O is nothing but the triangle faces. So OBCO, OCDO are the triangular faces. So now what are visible we are going to be retaining in thick lines, what is not seen we have kept it on hidden lines. So now we are going to be in this question. He says that we need to rest the square pyramid resting it on slant edges. So slant edges are nothing but OA, OB, OC, OD. I'll be able to place this on slant edges only if I'm going to rest it on corner. So if I'm going to take the pyramid, so I need to rest it on the corner, so corner should be on the right side. If I'm going to keep it on the edge, it is going to be on the resting it on triangular faces with respect to the second step. Now you can see that just because it is resting it on corner, I'm going to rotate it. It is like I'm going to make this pyramid to sleep. When I'm going to make it to sleep, it is going to be resting it on this slant edge, which is nothing but this one. Even here it is going to be resting it on that slant edge. So if I would have kept it resting it on edge here, then it is going to be resting it on one of its triangular faces. So that is the reasons why we are going to be start keeping resting it on corners. So this is very important thing. When there is a slant edges, that means first step, rest it on corner. In solids we are going to keep corner on the right side. So for square, even if I'm going to keep it here, even I can tilt it towards the left, but when it comes to the pentagon, here it is going to be edge. So throughout all the solids we are just going to be tilting towards the right, so that is the reason why I'm going to consider the right side. So now here we need to draw the square pyramid. So when you're going to be drawing, the first thing is you're going to be drawing the one of this reference line. So from these points draw 45 degrees angle line. So this is important if you're going to be drawing the first step wrong. If you're going to make some rhombus, parallelogram in the top view, the entire problem whatever you're going to be solving will not be a square pyramid. So this is very important. First thing is draw the square properly. So this one, the side length is 35. So I'm going to tilt this to an angle 45 degrees. So this angle should be 45 degrees. I'm going to be, if you want you can just draw a line, extend, cut an arc to a side length of 35. Similarly I'm going to be drawing it from the other way. So this side length is 35 and angle should be tilted to 45 degrees. So similarly with the same length I'll be cutting an arc with the compass. From here cut an arc, make sure the diagonals is going to be coming properly, which is going to be parallel and also perpendicular to XY line. So from this I just make it 35 and 45 degrees and here. So now this is just the reference line. We can just take it with the help of grids. Now outer boundary should be thick lines. Then what we are drawing is pyramid. So pyramid means all the slant. So top view, all the slant edges is going to be drawn in thick lines. So this is very important. All the slant edges is going to be in thick lines in the top view. That is what this is a wire frame. So now I'm going to make this thick line. This is thick line. From here I'm going to draw thick lines. So this is just for the reference. I'll just keep it here. Just make sure when you're going to be drawing it, write the prefix, which is nothing but square 35. So this point is when I'm going to be considering the top view, I don't have any top flat surface, so only the base edges here. So this is what I'm going to see it. So there is only A is visible, there is nothing A1 here. So this is A, this one is B, this is C, this is D, this is O. O1 is not visible. So now I need to be drawing the front view. So front view, all these projection lines should be in thin lines. Project these lines. See the nearest point for an observer. First thing is the height of the pyramid is 60. So from here I just represent height equals 60. Outer boundary of the solid should be in thick lines. We have just joined the outer boundary of the solid. When I am going to see it from here, I will be able to see this A dash is seen, this point B dash is seen, but D dash is not seen, C dash is seen, this is O dash, O1 dash is not seen. Now which is the nearest point for the observer is B. So line joining B must be drawn in thick lines. So from here it should be thick line because it's nothing but the slant length. So here you can see that in front view. So if I'm going to keep it the wire frame, this edge is seen. So but this edge is not seen. So that is what has been drawn. The next step is we need to resting dot slant edges. So here I'll be making it to restrict on slant edge by tilting it 90 degrees. So you can see that it has been, this pyramid has made to slip where it is going to be resting it on the slant edge. So I need to construct this. So if I need to construct this, first thing is I measure this length, which is 64.9. so here it is going to be equally inclined, that means even this should also be equal to 64.9. so also I need to find this distance, 49.5. now I'll be cutting an arc, which is nothing but I need to keep this OC on the XY line. So this is nothing but C dash, I'll be representing it here. So I'll go for arc by center point. So from here I'll take the distance, which is nothing but 64.9. Next is from this point I'll take this measurement from C dash to A dash, which is equals to 49.5. then from O to A, which is equal to 64.9. from this point I'll cut 64.9. now I'm just going to be joining these lines. Until here. Now I'm going to take this measurement from C dash to A dash. I'll take this distance, I'll cut an arc with the compass, and I'm going to draw it. But in the software it is not the same way how we are going to construct it manually. So get this, all these construction lines we need to be deleted, all this should be in thin lines. I just kept it for the reference. Now you can just keep the annotations. So while keeping the annotations, if you're going to be changing the annotations, see, keeping it here instead of if you keep it here, the final view will not come correctly. Similarly, if I'm not going to be checking the annotations properly in the top view, again will be not able to draw it properly. So first thing is I'm going to go for projecting this in its top view. So this line is just for you to understand the concept. So from here I'll be projecting this. So this point is O till this point O, go to this A, keep the annotation where A is, then move to the point B and D, move till here, then this point should be here. I'm going to trim the excess lines. So first thing is we need to join the outer boundary of the solid. So from here till this point and to this point. First we shall give its annotation. So this point is O, this point, do not place A here just because A is here. See, the view A has been rotated right side, A is here. If you go to keep it A, then the final view will not come correctly. So you just have to see this. This is very important. See where A is. So this point is A, this point is B, this becomes C, and this becomes D. Next thing is we need to join the outer boundary of the solid. So from here till here, the nearest point for an observer is A. That means line joining A must be in thick line. So from A it has been joining to A to B, A to D, A to O. So this is A to B, this is A to D, and this is A to O. Which is the farthest point? The farthest point is C. So line joining C must be in hidden lines. So C to B comes outer boundary, C to D outer boundary, remaining is C to O. Now we are going to project the axis line anyway will not be visible because of the thick dash type line, but A, B, C, D face is visible. That means the axis point O1 is going to be visible. So this is what we are going to be seeing even with respect to the solid. So this is the top view. We will be able to see two triangular faces, one bottom face. So the same thing, if I would keep this one in wireframe, view is going to be seen. This is the hidden edges because it is actually from this point till the apex. In top it is not seen because of this visible edge dominating it. So the same view we have got it. The next thing is what they have given is the axis is inclined to HP at 45 degrees, which is similar to the previous problem. What we have done is with respect to hexagonal prism. So where he has given the axis is inclined, that means is given a true inclination. The same thing we are going to do, repeat it here, but for the square pyramid. So which is going to be 45 degrees. So I'm going to draw a line initially. So just draw a line. So next thing is we need to incline the 45 degree. Either it can be this way or this way. So previous problems we have tilted this way. Let's see how it is going to be seen when I'm going to tilt the other way. If you're going to tilt this way also, this is also correct. So from here I'll just draw a line and so this should be thin lines. So first thing is we are just drawn the angle. This is nothing but the true angle. That means we need to find for the true length, which is equal to the axis length is equal to 60. So I'll go for arc by center. So from here I'll cut an arc of 60. Then I'm going to draw the locus line. So this is nothing but the true length, which is equal to 60. We need to find its apparent length, which is 55.646 is the apparent length. So I'll just go for arc by center point. So move to this point. I'll just keep and cut a radius of 55.46. I'll cut it. So previous problem we have just kept the point here and we have cut it here. So in this problem I'm going to keep the, in pyramid I kept the apex nearer to the VP and base was nearer to the observer. So in this case let's keep the apex nearer to the observer. So here I'll just, instead of making it, I just keep the apex nearer to the observer. Previous problem I kept the base nearer to the observer. So even this is also the right way, also right way of solving it. So this is apex. So now I'll be drawing an apex. So I'll just take this point. So I'll just draw this line and I need to find the beta angle. So this is the beta angle is 50 degrees. Now I can just take the distance from this is point O. I'll take the distance from O to A, cut an arc. O to O1 is this one, extended. Then O to C, I'll cut an arc. Then take the distance from O to D, cut an arc here, cut an arc here. Similarly A to D, A to B, and you will be able to cut and you'll be getting it, constructing it. I'll just do the same way. I just stopped. I have constructed it. Now just keep the annotations. So B point is towards the left side, so you have to keep the B point here itself. Then C is here, then D point is towards the right side. Keep it here. You can keep it either apex near to the observer or base near to the observer, but there are some questions where they says that apex should be near to the observer. In that case you need to construct like this itself. Either it can be this way or this way. Finally I need to be getting its front view. So go for lines So just go to this projection. So this is point is O point. O is on the XY line. We need to keep it here. This point is A. A is still this point. B point is still here. C point is still this point, and D point is still here. Let's keep the annotation. Now we need to see that this is O. A is still this point A dash. This point is, it comes here B dash. We need to see the annotation properly. This is C dash, and this one is D dash. So the first thing is we need to join the outer boundary of the solid. So from O to A to B to C and to O point. So this is what the outer boundary of the solid is seen. Next thing is I need to see nearest point for an observer. A is the nearest point. Why it has changed it to hidden lines? This should be in continuous thick line. So only hidden line is between A to C point. From O to A it is going to be thick lines. Now the nearest point, the apex, we should not be considering it. We need to see the base point. So this is approximately the axis point, which is nothing but O. First nearest point is B. Line joining B must be drawn in thick lines. So B to O, B to C and B to A should be in thick lines. So B to A is already thick line, B to C already remaining is B to O. The farthest point for observer is D point. Line joining D should be in hidden lines. So C to D to A and D to A. So this one should be kept inside the bracket because line joining D is not seen in its front view. So that's what we're going to see even its front view. So here if I'm going to keep this in the wireframe, you can see that these are nothing but the point D in solid view that is not visible. So now we are going to project the axis line. From here this should be axis line. So this one we need to trim the axis line. We need to mention the beta angle. So beta is, select, beta is 50 degrees. In some software you'll be able to see 51 because there is between 50.4545. It is based on the accuracy what we have limited. So in this case it has taken 50 degrees.